wondered about the cost and effort involved in maintaining one of the 7 wonders of the world, the Eiffel Tower? 50 metric tons of paint is applied to protect 200,000 square meters of iron lattice work from rust every 7 years. Each repainting takes 25 painters working for 15 months to complete the job. 17 maintenance operations have been done so far since 1889. Had galvanized steel been used to build the Eiffel Tower, it would have required only 7 maintenance operations. Large-scale maintenance of galvanized steel and paint duplex system is needed only every 25 years. What does all this mean in terms of cost? This would have saved authorities at least $10 million in maintenance costs for the Eiffel Tower. Using modern-day prices, these savings amount to over 50% of the total construction cost. Infrastructure development today needs to keep swift pace with the demands of a new world, a world that is both cost and environmentally conscious. Iron and steel is one of the most important construction materials for infrastructure development. Unless steel is protected, it will corrode in most environments and lead to high maintenance costs. Galvanized steel is the best way to build sustainable structures that are long-lasting and very cost-effective.
Galvanizing process is such that if you clean the steel well, you are always bound to get excellent composite product, the composite material. The steel and zinc become one after galvanizing. It's an integrated product. The zinc and steel, they react in the galvanizing process, and it forms a metallurgically bonded coating with the base steel, which is totally different from other processes like painting, plating, spraying, etc.
That is why several structures all over the world have used galvanized steel. Structural design engineers specify galvanizing during planning and design stage itself to cut long-term maintenance and repair expenses.
Even if there is defect in a coating, the exposed portion doesn't get affected because zinc, surrounding zinc sacrifices itself for iron. So this sacrificial protection prolongs the corrosion protection by zinc by an order of magnitude. For example, a coating thickness of about 50 to about 60 micron in rural atmospheres can make the objects last for as long as 50 to even 60 years.
Singapore's Changi Airport, built 30 years ago, is famous for its works of art and in particular its man-made waterfalls, carved ponds and aquariums. The anti-corrosive protection of zinc has assured that these attractions are in pristine condition and will remain that way for decades to come.
This kind of a bonded galvanized coating gives excellent wear resistance and abrasion resistance during transport, during handling, during site operations, etc.
Recent studies carried out in Australia, Germany, Holland, Spain and Sweden on galvanized steel transmission towers have documented the outstanding service life that can be expected from galvanized coatings. The towers erected between 30 to 60 years ago still have some of their original coating and are expected to remain corrosion-free for years.
It is the corrosion which is causing the maximum loss to the railways. Yearly loss could run into few thousands of crores, and in some cases the corrosion of rails especially has led to accidents also.
In India too, change has begun. High-mast lighting poles and crash barriers are always galvanized. The intricate petals of the lovely Lotus Temple in New Delhi are reinforced with galvanized rebars. On Naini Bridge, Allahabad, and Mumbai's famous Bandra Worli Sea Link, the steel grooves that hold suspension wires are constructed with high-strength galvanized steel.
As far as galvanizing in railways is concerned, we are already galvanizing many items. These include electric masts, which have been used since 1960 and are still doing fine as far as corrosion is concerned. No sign of corrosion on these masts has been seen so far.
What is galvanizing? A factory-controlled metallurgical combination of zinc and steel that provides barrier and cathodic protection against corrosion. The first requirement is to remove oils and greases and old paint coatings. This is normally done in hot, strong alkali solutions or by abrasive blasting or by acid cleansing and rinsing. The next step is fluxing to prevent oxidation. The chemically clean, highly active steel surface is immersed in a flux solution that removes any oxide film that might have formed on the highly reactive steel surface after acid cleaning and prevents further oxidation before galvanizing. The structure is then dried and ready for galvanizing. The actual galvanizing reaction takes place at between 445 and 465 degrees centigrade. The dried steel part that results in the actual galvanized zinc layer. The steel structure is treated using the hot dip galvanizing method, which involves dipping the structure into a galvanizing kettle which contains zinc. Once this is done, immediately a metallurgical alloy is formed between zinc and steel, which results in a thin molecular layer of brittle, hard high-iron zinc alloy called the gamma layer. Next, a much thicker, hard brittle alloy layer is formed, which is called delta layer and contains 7 to 12% iron. On top of this, the zeta layer forms, containing about 6% iron, and finally the surface layer, which is virtually pure zinc, called the eta layer.
In case of the second and the third layer, they are twice as strong as the steel that it is protecting, therefore giving more utility, more ductility, more strength to the steel as compared to any other coating, whether it is a zinc paint or a zinc sulfate coat or metallizing also for that matter.
The galvanized structure is not only tough, but gets consumed by the atmosphere at a rate much slower than steel. It also coats corners completely and does not thin out at the edges. It is also very flexible and can be used on a variety of shapes and sizes. Finally, it's a self-check on the quality of steel, as galvanizing will not take place if the steel is not clean.
As far as lengths are concerned, they can very well be handled and managed by the current day galvanizing plants. And there is double end dipping processes which are also followed by galvanizing plants, where both the sides, perpendicular alternative sides can be galvanized, even for structural lengths which can range up to 12 meters or 14 meters in length.
One of the biggest benefits of galvanizing is its impact on the life cycle of the structures. A quick look at the life cycles under various conditions shows an application of over 610 grams per square meter can result in a service life of anything from 20 to 80 years, depending on whether it is in a heavy, corrosive industrial area or a mild rural area. The galvanizing process lends several advantages over painted structures. For galvanizing, thorough surface preparation is essential, whereas in painted surfaces, uneven blast cleaning reduces the success rate by 60 to 80%. Galvanized surfaces are able to withstand air pollution and humidity, while painted surfaces are affected. The galvanized coating is even and formed through a metallurgical reaction, whereas in painted surfaces, the process is an additional barrier layer and not organically bonded to the structure. Galvanized coating is thicker and complete at the corners and edges, an important advantage over most organic coatings, which tend to thin out in these areas.
We have experienced that wherever the dip galvanizing is done, it must last, better last, long lasting than when you do epoxy coating or any oxidation that we do by painting, zinc chromate paint and the two coats of enamel paint that we apply, that doesn't last as long as the galvanizing lasts on structural members. Paint of course does give a protection, but it has to be repeatedly pre-painted for higher protection, for longer life. But hot dip galvanizing is properly done, this minimum micron that is required, doesn't require any attention.
Let's understand life cycle cost by an example. 3 similar steel structures are to be erected in similar kind of environment. For corrosion protection, one decides to galvanize it at an average initial cost of rupees 11,000 per ton of steel. Another one goes for fusion bonded epoxy coating at a cost of rupees 8,500 per ton. And the third person paints it for rupees 7,500 per ton. After 5 years, galvanizing and fusion bonded epoxy need no maintenance, while the structure that was painted has to be done again, hence the cost of rupees 7,500 again. After 5 more years, fusion bonded epoxy also needs maintenance at rupees 8,500 per ton. Thus, fusion bonded epoxy needs maintenance in every 10 years, while painting needs maintenance every 5 years. For a structure of life cycle of 50 years, the total life cycle cost is rupees 11,000 if it is galvanized, rupees 42,500, about 4 times if coated by fusion bonded epoxy, and rupees 75,000, about 7 times if just painted. Here, for simplicity, we have not considered inflation. Actual maintenance cost for fusion bonded epoxy and painting will be much more than these. Moral of the story: if you are building for long term, galvanize your steel. IS 11759 lists various zinc touch-up methods like zinc alloy solders, zinc spraying and zinc painting for repair of damaged hot dip galvanized coatings like in welding. After welding, you can rest assured that all the bare spots will be well protected. 21st century requires 21st century building materials that promise long-term structures that are not only cost-effective to maintain and environment-friendly, but also attractive to look at.
I feel that in about 5 to 8 years' time, we can go for 30,000 tons of zinc coating on Indian Railways, which will save many thousand crores of rupees for Indian Railways.
I may not be wrong in suggesting that the demand is only going to go 4-fold or 6-fold in the coming years, because there are going to be quite a lot of policies which are going to concentrate on the long-standing and long life structures.
Our country should make sure that all the responsible authorities specify use of hot dip galvanized products in most of the constructional activities.
I think it's a better method than anything else that I have come across for protection of steel.
Therefore, for corrosion protection, think of zinc. Zinc is the best answer.
It is crucial to plan for galvanizing at the design and planning stage itself, along with other engineering material, and not consider it as just an anti-corrosion material. It's only then that the cost and maintenance benefits that galvanizing gives can be truly exploited. Galvanizing, where your first cost is the last cost.